Hello students, today I am here with the multiple choice questions for the subject lasers. So the first question is the coherent length for visible light is. Okay, so to find out the one of the correct options we need to solve this. So the formula to find out the coherent length L is given by lambda square divided by 2 delta lambda. Okay, so in this question we have been just given visible light. So visible light range, everybody knows this is around 400 to 700 nanometers, or you say 4000 to 7000 angstrom unit. Fine. So using this only we need to get this coherent length. So to get lambda, okay, so as you have been given range, how will I find out lambda? I'll say lambda 1 plus lambda 2 by 2. What is lambda 1? Is, suppose I say 400 nanometers plus 700 nanometers divided by 2 gives me 1100 nanometers. 1100 by 2 will give me 550 nanometers is my lambda. Okay, afterwards, what is delta lambda? Delta lambda will be the difference. Difference will be the higher value minus the lower value. So this gives me 300 nanometers. So after knowing this lambda and delta lambda, I'll say L is equal to 550 into 10 to the power minus 9 bracket square divided by 2 into 300 into 10 to the power minus 9. So if we simplify this, okay, what you get basically 550 square 10 to the power minus 18 divided by 600 into 10 to the power minus 9. So if you simplify this, you get the answer to be 504 into 10 to the power minus 9 or 504 nanometers. Fine. So that's the reason out of which the answer will be A. So this is the way we can solve the question paper. Okay. Second question, the coefficient for stimulated emission will be or dash for wavelength of emission of 6000 angstrom unit and lifetime 10 to the power minus 6 second. The first thing you need to understand over here what they have asked. Coefficient of stimulated emission, that's what they have asked, B21. Okay, what is the formula for B21? B21 we have seen in module 1, which is C cube into A21 divided by 8 pi mu cube H into nu cube. Okay, now everybody knows value C is equal to nu lambda. So therefore lambda will be C by nu. So I'll replace this C cube and nu cube by lambda cube. That is the first thing. Along with that, A21 is nothing but 1 upon tau SP, which is my lifetime. What is this value given? 10 to the power minus 6 second. Okay, so this will be replaced by this number. So how will we change the formula now? B21 is equal to lambda cube into A21 divided by 8 pi mu cube H. Okay, out over here the value of mu is also 1. Now what is mu? Mu is your refractive index of the medium. It is not mentioned, so we'll take the value to be 1. So what are the things given? Lambda. Okay, what is the lambda given? 6000 angstrom unit. So you can say 6000 into 10 to the power minus 10 meters, fine, raised to cube divided by 8 into pi into, I'll say 1 cube into H is your Planck's constant, and don't forget A21. A21 is 1 upon 10 to the power minus 6. If you forget this, the answer will be wrong. Okay, so if you simplify this, the answer over here is 1.2980 10 to the power 19 or approximately 1.3 10 to the power 19. Okay, so over here the value is 1.3 10 to the power 19 meters per kg is the perfect answer. So answer is B, 1.3 10 to the power 19. Fine. Now after this we'll move to the next question. Next question is a material used in laser resonator of length 20 centimeter has gain factor of 0.0005 per centimeter. The reflectivity of one mirror is 100%. The reflectivity of other mirror will be how much? Okay, so this will be solved with the formula gamma is equal to 1 upon 2L ln 1 upon R1 R2. Fine. So over here, is L given to you? Yes. How much is L given to you? L is given out to be 20 centimeter. Okay, and how much is the gamma given to you? Gamma is 0.0005 per centimeter. How much is R1? R1 is 100%. And how much is R2? R2 we do not know, we need to find out. Okay, so how we change the formula? Take first this term together. So we can say e to the power, so taking log on both the sides, we say e to the power 2L gamma is equal to 1 upon R1 R2. Fine. Afterwards, we know R1, we do not know R2. So what we'll say? We'll say therefore R2 is equal to 1 upon R1 e to the power 2L gamma. Fine. Substitute the values. So how much is my R1? R1 is 100%. E to the power 2 into 20 into 0.0005. Okay, I am not shifting because this is centimeter, this is per centimeter, will get cancelled. So don't have to bother about that at all. So simplify this, 2 into 20 into this. Okay, this gets the answer 1 upon 1.020. Okay, and if at all you find out 1 upon 1.020 gives you 0.98, or I can say 98%. So the answer will be C. So this is the way we will be solving the numericals for the examination. Okay, next question. Next question, the coherence length of HENE laser, they are given the wavelength, will be how much, how many meters if coherence time is 26.7 nanosecond. So I need length and coherent time is given to you. So what formula I'll use? I'll use LC is equal to CTC. What is LC? The coherent length which I need to find. And what is TC? Is the coherence time. So how much is C value? Which is 3 into 10 to the power 8 into 26.7 10 to the power minus 9. Okay, so if you simplify this, 3 into 26.7 gives you 80.1 into 10 to the power minus 1, so which gives you around 8 meters. Okay, so therefore the answer will be A. So this is the way we can simply solve the question. Now comes to question number 5. Question number 5 is, assuming uniform intensity across the beam, calculate intensity of a laser beam of 20 milliwatt, okay, power, and having a diameter of 1.3 mm. This is the question given. So to solve this, what formula will I have to use? I need to find out intensity. So intensity I will be given by power divided by area. So how much is the power given to you? Power given to you is 20 milliwatt. Okay, and A is how much? A will be pi r square. How much is the value of r given to you? You have been given a diameter of 1.3. So you have to divide 1.3 by 2, gets you the radius. Square it. Okay, so if you multiply 3.14 into 1.3 by 2 square, gives you the value 1.32 mm square, because this is 1.3 mm. I am keeping it mm only. Okay, so this gives me how much is P? I said it is 20 milliwatt divided by 1.32 mm square. Okay, if you simplify this, gives you 15.15 milliwatts per mm square is the answer for the intensity. So 15.15 milliwatt per mm square. So answer is this, correct. Okay, moving to the next question. Question number 6. Along with axial modes, a laser output is characterized by dash modes. So this we have seen in the last third module. Okay, where I think second module, not third, second module. So here what we are seeing the TEM case. Okay, so there we have mentioned that along with the axial modes, a laser output is always characterized by what is called as TEM modes. Okay, this is very simple theoretical question. Then comes next one. A long radius cavity resonator configuration has two dash mirror. Okay, now when we have seen the four types of configuration, laser configuration, we have seen it that for this long radius cavity we have the combination of such type of mirror, and distance was little longer, L was little longer, so here we definitely need two concave mirrors. This is the diagram. This is also simple question. Next is question number 8. Which of the cavity configuration is used in commercial lasers these days? Okay, so over here the question is pretty obvious. Everything had a problem, something or the other. Plane parallel, confocal, long radius, hemispherical. Everything has got some plus, some minus point. But this long radius is used more because this is more stable. So I'll say these days commercially long radius configuration for the resonator cavity is used. Okay, then move to question number 9. Question number 9 says the product G1 G2 is equal to how much for a laser cavity consisting of two concave mirrors. Distance between the mirrors is 1 meters and each mirror has radius of 60 centimeter. Okay, so I need G1 G2. So what is the formula for G1 first? G1 is 1 minus L by R1, and similarly G2 is 1 minus L by R2. So we need to know G1 G2 product, and we have seen the condition that 0 less than G1 G2 less than equal to 1, which means the cavity is stable. Okay, now over here we need to find out how much is L given to you. L is 1 meter, so we can say 1 minus 1 divided by how much is the radius. Radius R1 is 60, so we'll say over here 0.6, 60 centimeter. So this is 0.6 meters. Same thing here also, 1 minus 1 upon 0.6. So how much this will give me? This will give me 1 minus 1.67. This is also 1 minus 1.67. Okay, so 1 minus 1.67 will give you definitely minus 0.67. This is also minus 0.67. Okay, if you multiply them, what will write? Minus 0.67 into minus 0.67 will give you plus 0.4489. So this value is in middle, 0 and 1. Therefore this thing will be stable. Okay, so we can say the answer will be plus 0.4489. So this is my correct answer. Question option number D. Okay, now next is question number 10. Which laser is used to weld detached retina? So we have seen in the last module there are many applications in different field. So as far as medical field is concerned, okay, you have seen that the laser has got lots of advantages as far as eye surgery is concerned. People can take care, like the eyes can be get operated by the laser to remove the positive number, negative number, to weld the given the retina, okay, to detached retina. And even the these days there are many operations okay, final point cataract operation also you need to use the laser. So basically in this case argon laser is preferred for weld detached retina. Okay, next question number 11. Which laser is used for cutting materials like graphite, very hard, diamond, tungsten, carbide, etc.? So in this case, which laser is used? So the obvious answer will be CO2 laser. CO2 laser is basically used for cutting the hard materials. Ruby, HENE and dye can't be used for that. Okay, next question. In ruby laser, the host crystal is. Now we are seeing in ruby laser which crystal is used, in HENE which crystal is used, in DIAG which crystal is used. Okay, so therefore, and this also used for the dye laser. So obviously in ruby we need to use Al2O3. So correct option is B. Next question. In CO2 laser, dash plays similar role to that of HE in HENE laser. So we have seen in CO2 laser, okay, you need to have more concentration of nitrogen also. Therefore, nitrogen plays similar role to that of HENE laser, HE in HENE laser. Fine. Next question, which is also here itself you get answer. The discharge tube of CO2 laser is filled with a mixture of CO2, N2 and HE gases in the ratio. So this is a very typical question. So we have seen when we have studied CO2 laser that you need to have a mixture of CO2 plus N2 plus HE in the ratio 1:, this is 1:4:5, correct? So that's the reason the correct option over here will be 1:4:5. Answer number C. This is correct. Okay. Now after finishing this, we'll go to the next question. Next question is question number 15. Question number 15 is what should be maximum length of the cavity to have a single longitudinal mode oscillation for a HENE laser whose half width of gain profile is 2 into 10 to the power minus 3 nanometers. Okay. Now to solve this question, we need to use a formula which is L is equal to lambda square divided by 2 mu delta lambda. Okay. Now over here, how we got this formula? We got this formula from the theory part. Delta lambda is equal to lambda square divided by 2 mu L. Okay. So as we wanted L, okay, what should maximum length? That's why we have come from this formula over here. Okay. Now in this case, what is given and what we need to do? We need to find out L. Is lambda given to you? Yes. Lambda is given out to be HENE laser, so it's obvious. So lambda is 6328 angstrom unit. Okay. Then obviously mu will take it, refractive index will take it as 1, and delta lambda will be, they have given it, which is profile half width will be 2 into 10 to the power minus 3 into 10 to the power minus 9 meters, because this is nanometers. Okay. So this will give me 2 into 10 to the power minus 12 meters. Fine. Now if you substitute these values over here in the formula, we'll get L is equal to 6328 into 10 to the power minus 10 bracket square divided by 2 into 1 into 2 into 10 to the power minus 12 meters. Okay. So if we simplify this, we will come to the simplest possible answer, which is 0.1 meter. Very interesting one, such a big number, but finally you get answer 0.1. Therefore the option A is perfect. Okay. After this, we'll go to the next question, which is in case of semiconductor laser, P and N type materials must be, so even this we are seeing during theory that they must be degenerate. Fine. Simple question. Next is CO2 laser has dash vibrational modes. We have seen CO2 laser basically has three vibrational modes. Which three? One is the stretch one, second is bending, and the third is asymmetric. So depend on the position of C and O2, like this or like this, or C with O, one arrow going here and other arrow. So this way you will see the asymmetric nature. So one is stretch, other is bending, and the third is asymmetric. These are the modes of the vibration for the CO2 lasers. So these are a total 17 questions I have finished. If the response is good, definitely I'll go for the remaining at least 13 more to complete the 30 questions. Okay, thank you very much. Go through it. Anything not clear, feel free to ask.